This is movie number 2 to help students make up the mole concept when they missed it. We're going to take a look at some questions here today. And we're going to be doing one of each of these, and then you can pause the video and try them. And I've provided an answer key for this so that you can try to get the right answers for them. So I'm going to do the first example of each one of these questions. So how many atoms are in the following? So I have 2.5 moles of niobium. I'm going to put that on the left side. Now this question has the word mole in the question, so I know this is going to be a one-stepper. So times and then equals. And I want to know how many moles of niobium that is. Okay. Actually, I want to know how many atoms it is. So let's change that to atoms. Okay, so if I want to know how many atoms that is, I don't need to visit the bakery because that's my quantity. I'm just going to write 6.02 times 10 to the 23rd. Notice I'm using the E button because that's how you're going to put it in your calculator, over 1 mole of niobium. And this, of course, will be atoms. And that's how a question like that is done. Now I'm going to take 2.5 and I'll multiply it by 6.02 E23 in my calculator. I'll end up with 1.51 E24 atoms of niobium, which means times 10 to the 24. All right, next question here says, how many atoms are in the following? I don't see the word mole in my question here, so I know this is going to be a two-stepper. So I'm starting with 25.0 grams of argon. And my other side here is going to be atoms of argon. Okay, I can immediately set up my proportions here. They will follow very similar to the mole concept or the dozen concept. I'm going to put 1 mole on top here. And I'll put 1 mole on the bottom here. So anytime I don't see the word mole in my question, I know I'm going to be 1 mole and 1 mole like this. This one, I'm looking for atoms, so I can go 6.02 E23 atoms of argon right here. Now atoms is with the atoms, see? You always have to have whatever is on this side must be on this side also. Now I need grams over here. Okay, I don't know the molar mass of argon, so I just have to go to the periodic table and look at argon. Argon is like 39.9. And maybe I'll carry a 4.8 next to that. That might be good enough. Okay, so let's go back to the question. So 39.948 grams of argon. Now mathematically, I'm going to take 25.0 divided by my 39.948 since it's on the bottom, and times by 6.02 times 10 to the 23rd. Anything that's on the bottom is going to be multiplied, or is going to be divided. Anything on top is going to be multiplied. My answer comes out to be 3.77 E23. All right, let's take a look at one more example. And again, you can pause the video and try the next one, or wait till I'm all done, and then you can work on the other ones. And again, I provided my answer key. How many moles are in the following? So I have 4.4 E23 atoms of sulfur or selenium. I'll put that over here like this. I know this is a one-stepper because the word mole is in my question. I'm trying to find moles of selenium, so I'm going to have the 1 mole on top. And I'll divide by the 6.02 times 10 to the 23rd atoms on the bottom. And see how atoms will cross atoms and we're left with mole on top, which is what we want to find the answer to. And it's 0.731 moles is our answer. And that's how we are doing mole conversions, okay, when you don't have exactly 1 mole. In our next video, we'll be looking at empirical formulas.